So we're going to start off this prop right here with, notice I have a corner plane for you. You've got 2 points, and obviously, just like any given 2 points, I'm probably going to ask you to find the distance between the 2 points. And that is our theme for today. I want you to find a distance between 2 points. Now, if you were to do this in real life, I say here, here's one location, here's the other location on the other side of the building. Can you find a distance? What would you do? What would you do?
I count my feet.
Okay, or if I give you like tools, what would you need?
Giant ruler.
Do you actually use rulers? Tapes or something like that, or remember with the people walking around with the wheels like that, they're actually measuring that way too. So they do have tools for you to measure it outside. But think about this. If it's small enough, you certainly do measure it, right? Try to measure it manually, do it yourself. But we're talking about like thousands of miles, and you want to get an exact value. Are you able to walk 1,000 miles to measure it?
Yeah.
No, right? So we need to have another way to do it. And mathematically, we do have a way to figure out the distance giving any 2 points. I don't care if it's like 5 miles across, or it doesn't matter. We still definitely find it. But before we start on this right here, I want to kind of remind you about what we covered last week. Or not last week, but the week before last week. Remember the Pythagorean theorem? Mm-hmm. Okay. Remember the right triangle here, and I said that the triangle had 3 sides. And more specifically, it has 2 shorter sides and longest side, right? And the longest side is called what?
Hypotenuse.
Hypotenuse. And look at this right here, this right triangle. If I'm going to label this A, and this is B, then C is your longest side. And the way that we identify the longest side is by looking across from it, and it should have a 90-degree angle right across. Is that correct? Okay. And why do I have the squares right here? Remember what we did with the squares? What are we doing? Yes?
2 smaller squares make a big square.
Yeah, exactly. 2 smaller squares right here, square 1 and square 2, if you actually cut them up and put those 2 in square 3, they will actually fit perfectly inside square 3. And that's the reason why we have them like this. By the way, what is the area of square 1? B squared, because B times B, right? And what is this area of the square number 2? A squared. And of course the area of square 3 is C squared. And that's the reason why we have this particular formula, or the Pythagorean theorem is called A squared plus B squared is C squared. Okay, we're clear on that end, on how this came about. Okay, now we understand this, that today's lesson is not that much different. You think about this for a moment. I have 2 points right here. And I asked you to find a distance between the 2 points, just like this. Okay, now look. Does this remind you of a line between 2 points? And we know that every line has what? A slope. Interesting. Can we find slope of 2 points?
Yes.
How do we find it? Remember?
Rise
Rise of run. Oh, wait a minute. Rise of run. Watch what happens. If I'm going to be doing rise of run, does that mean I'm going to have to go down certain units? And in this case, to get to this point, do I go left or right? Right. And all of a sudden, because I go down and go right, this forms a 90-degree angle. And all of a sudden, this is a triangle. Right triangle. And it just goes right back to our Pythagorean theorem. If I want to find a distance right here, which is like C, isn't it? All that I need to know is figure out what this distance is and what distance is. Is that correct? And basically, A and B are our rise and run. Do we know how to find our rise and run?
No.
Oh, we can count, right? But what if I don't have the graph at all, or if it's too big to count? What would you do? What's the best way to do it? How do we find our rise and our run? Subtract. Okay, very good. So we're getting somewhere. Think about this. So here's the questions. Is there a shortcut for this? Because I don't want it to be exact forever. Meaning rise, rise and run. And there is. Watch this. If I give you 2 simple points. Imagine I have 1 point right here, which is add 3 negative 1, right? Another point that I can give you is right here, which is add 1 and 3. And just like the other one, if I ask you to find the distance between the 2 points, notice distance between 2 points. It forms a line. And because it's a line, it has to have a slope. Is that correct? And a slope is defined by our rise and our run. And if we actually draw it in there, we see that we have a right triangle. Right? So now our challenge is going to be, how do I find this distance and that distance? This is our rise, this is our run. Now, Anna earlier said, wait, we can actually subtract, right? When we subtract the 2 points, what are we finding again? Our what? Slope. So let's take a look. Here's 1, 3. Here is 3, -1. If we're going to be subtracting right there, and of course, you can always defend the answer saying, I can certainly count for it because it's easy to count. Yes, you're right. But what if the number gets a bit more difficult, like fractions or decimal? Then it's a lot easier if you're just going to do a subtraction problem like this. But let's subtract. What is 1 minus 3?
-2.
-2. What is 3 minus -1?
2.
What is 3 minus negative? Everything you have a minus negative. That would become a plus, right? Don't forget. And it's a 4. And isn't this your, which one's the rise?
4.
The 4, which is like the y component of it, right? And of course, this is the x component of it. Is that true? Okay, let's put it on our thing. Here, we have -2 and we have 4. So 4 is this portion of our triangle. Is that correct? Because that's pertains to our rise, and this is a -2, correct? But because we're talking about the distance, do we care about the negative?
No.
No. So can we just assume that this is also positive? You see it? We're talking about the distance of a figure. So even though it's a negative, we don't really care. It's still going to be positive to us. So look, we have a 4 here for this leg. We have a 2 here for this leg. How do we find the missing leg? You see what's happening?
Where?
And our missing leg happens to be what here? What is this called? The hypotenuse, or the longest side. And we know that it's the 2 shorter sides, square, that equals to the longest side square, right? So if we want to solve for this, how do we set this up?
4 squared.
4 squared
Plus 2 squared.
plus 2 squared equals to c squared. There you go. Got that right there. And notice how I get the 4 and 2 from. Right there. By using our slope. The slope will give us the 2 shorter legs. So please, if you need to remember this, your slope here, when you set up, by subtracting 2 points, will give you the 2 shorter legs of your right triangle. See it? That's the thing that we need to find. Find the 2 shorter legs first, and then once we have the 2 shorter legs, we square them both and add them together, and that should equals to our longer leg square, right? And let's solve for this. What is 4 squared? 16. What is 2 squared? 4. And that's what we have so far. 16 plus 4? 20. How do we get rid of the square?
Square root.
Square root it, right. So we square root both sides. We can certainly simplify square root of 20, right? What is the square root of 20?
2.
If we break it down, what do we have?
2 square root of 5.
2 square root of 5. Now, how many of you still like, oh, I don't remember how to do that? How do I get 2 square root of 5? Well, think about this. 20, you break it down, don't you have 4 times 5?
Yeah.
And then 5 is already prime, I don't do anything to it, but the 4, we know it's 2 times 2, right? And it's a pair. That's why we take that outside. Agree? That's how I got 2 root 5. Another question though, if I asked you to approximate it, do you remember how to approximate the square root of 20?
No.
Do you know how to approximate it? You don't remember?
9.
Remember, you got to ask yourself, when asking you to approximate the square root of a certain value, you always think about what is the next perfect square number, the biggest perfect square number and the smaller perfect square number.
5.
Okay, you said 4 and 5. So 5 is 25, right?
Yeah.
And 4 is 16. Is the square root of 20 in between the 2? It is. So you know that the answer has to be about 4 point something. Agree? But we just need to figure out, wait, is square root of 20 closer to 16 or is it closer to 25?
16.
So that it has to be closer to 4. But isn't 20 like around halfway?
Yeah.
But it's a bit more to the left of it, so can we approximate it to be about 4.4? It's not exactly 4.5, but it's 4.4. So there it is, approximately 4.4. Now, if you have a hard time visualizing it, I would suggest that you write it out like this. square root of 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. See how that works? And then you just have to say, okay, that means I have 3, 4, 5, 6, 7, 8, 9, 10 numbers. Split that in half, I should have 5 on each side. Is that correct? If square root of 16 is 4 and the square root of 25 is 5, halfway is 4.5. And isn't square root of 20 on the left-hand side 4.5? That's why we approximate it to be about 4.4. And that's how we approximate square roots. If we don't have a calculator, of course. But if I just say, hey, just simplify it, and that will be your exact answer, 2 root 5. Question on how this is done. Okay, so let's kind of sum this up a little bit. If I give you any 2 points, and I ask you to find the distance of any 2 points, the first thing that should pop up on your mind is, okay, if I have 2 points like that, let's find ourselves the 2 legs of, because notice that with 2 points, I can form a right triangle for it, right? A right triangle has 3 sides. Okay, the distance that I want to find will always be the longest side, which is the hypotenuse, which means I have to find the 2 shorter legs. To find the 2 shorter legs, I just have to find the slope of it, of the 2 points. And this is exactly how I got the 2 shorter legs. And because they are distance of a triangle, I don't care about negative. I keep everything positive, if you notice. You see? And once I have the 2 shorter legs, I square them both and I add them together, and I will try to find my longer side. In this case, the hypotenuse. Okay, so you see how that's done? All right, let's go back to this problem right here again. And think about this for a moment. I got my 2 points once again. I need to find the distance of this, but if I want to find the distance of this, I need to find the 2 shorter legs, right? How do we find the 2 shorter legs again?
Subtract.
Subtract it. Let's subtract. Let's see what we got. If I'm going to be subtracting it, here's negative 2 and 3. Here's this 8 and negative 20. Notice the step that we're doing. And let's subtract. What is negative 2 minus 8? What is negative 2 minus 8? Negative 10. What is 3 minus negative 20?
23.
23. Very important, right? You need to subtract it correctly. If you mess this step up, your entire problem will be wrong. Okay? Now, you just got yourself the A and the B kind of sense, right? The 2 shorter legs. If you have the 2 shorter legs, what do? You square them both. So, in this case, negative 10 squared, if you square it, you still get a positive value. That's why I told you that we don't care about the negative values at all. Either way, you get that positive anyway. So here's a 10 squared, and here's a 23 squared, and that should add up to what?
C squared.
The C squared, the longer legs of your triangle, right? What is 10 squared? 100. What is 23 squared? 529. Okay, now for those of you like, how did she remember that? Well, it takes practice. You see it a lot, all of a sudden you remember. That's a guarantee. What is 100 times, plus 529?
629.
629. C squared, we take the square root of both sides. Let's approximate it this time. What is 629 closest to? That is the perfect square number. Give me a perfect square number that is closest to 629. Remember the list that I gave you before? What is that number that's closest to
25.
25 square is?
625.
625. So that means 629 is the closest to 625, right? 625, the square root of 625 is 25. So we know that it's about 25, but since this is a bigger than 625, we can say about 25.1 if we want to say it that way. But that's how we approximate our square root value. Okay? That chart will definitely help you, and I definitely strongly recommend you to at least try to remember at least all the way to 25 squared. Be very useful. Okay? Alright, so do you see the basic concept of how to find a distance between 2 points? Find the slope first of the 2 points. That will give you the 2 shorter legs. Once you have the 2 shorter legs, it's pretty much set and done, right? You square both legs and then find the longest leg, which is the hypotenuse. Okay? And that will always give you the distance of the 2 points. Now that we see it, can you go ahead and work on that for me? Go. Alright, so I give you 2 points. I want you to find a distance between 2 points. Remember I told you that some people want to have like a picture of this to have a better handle of things, which is fine. Look at this right here. You got yourself 2 points, so I can just certainly randomly just plot them. You don't have to be accurate about it. Just say, oh yeah, I have 2 points right there. I don't want to find a distance between these 2 points. Okay? And this is for, I mean, I gotta calculate this again. Give me one. Okay, so here's the 2 points. 4, -1. That's 1. And here's -2 and -5. And you can clearly see that I can make a path for it, right? And that path happened to be your slope, rise over run. And that at least reminds you that, hey, I can certainly find the slope of this, these 2 points. So how do we find the slope?
Subtract.
Subtract, there you go. So we got 4, -1, we got -2, -5. As I subtract that, don't forget that you need to manually put in your subtraction sign. Don't leave it out. 4 minus -2.
6.
6. -1 minus -5. 4. And that's how I have to. What do I have right here?
X and Y.
Y.
Or if you put that into your triangle, what do you have?
A and B.
A and B, basically. The 2 shorter legs, right? That's what you need to know. What you solve right here will give you the 2 shorter legs of your triangle. You put it back right here, think of it as, oh yeah, that's 4 and that's 6. See it? And if I have the 2 shorter legs, can I find the missing leg? Or the longest leg in this case? Yes, you can, right? How do I solve this now? Square both. Alright, so 4 squared plus 6 squared equals 2.
C squared.
C squared. 4 squared is 16. 6 squared is 36. 16 plus 36?
52.
52. And how do I solve for C? Square rooted. Okay, so for some people, you break that down, you simplify it, and you got yourself exact answer of 2 root 13, right? Now, if you were to approximate it, what would it be?
7.2.
About 7.3?
I put 2.
Yeah, 7.2, 7.3. It's fine. But around that. Okay? We're good? So these are the exact step one how we approach this kind of problem. Every time I give you 2 points, find a slope for it. Because using a slope, we're able to find the side and the length of the 2 shorter legs. And once we have the 2 shorter legs, we can find the longest leg. Okay? Any questions? Now I'm going to give you a variation to this problem. It's going to shift a little bit. Watch what happened. This time I said find the possible values of A if the distance between the points at 7, 5 and A, -3 is 10 units. So I'm not asking you to find the distance between 2 points anymore. Instead, what am I asking you to find?
The missing variable.
The missing variable, the missing coordinates in this case. See it? So I do not know exactly where this point is. So let's go ahead and randomly or arbitrarily put up the point. Let's call this 7, 5, and let's call the other point right here A, -3, right? This distance from here to here, do we know that distance yet?
No. Oh wait.
Yeah.
It is. It's there. This time I gave it to you. What is it?
10.
10. So I gave you the longer leg, the longest one. If you were to put that down as a triangle, right triangle, is what you're saying. I have the hypotenuse already defined, which is your C, isn't it? I don't know what my A and my B's are, but can I find at least some of them? Let's find it. How do I find it? Subtract, very good. So 7 and 5, and 9 and -3.
That's an A.
Oh, I'm sorry. See that? I kind of missed it. A. A. There it is. So, let's subtract it. What is 7 minus A?
7 minus A. 7.
It's not 7 times A. What is 7 minus A? 7 minus A. The same thing. 7 minus A is 7 minus A. What is 5 minus -3? 8. Oh, wait. So at least we know one of the length is, right? 8. And that's the y part of it. So this is 8. Agree?
Yeah.
So according to this, if we have two sides of the out of the three sides, we can always find it, right? But we need to know how to set this up. This is the side that's missing. Let's set up a variable to define that. What do you call that? Let's call that B. See, the thing is, if you call that B, I don't want you to mix it up and think that A is this side. No. A is just a coordinate of that, right? Okay? So fine, let's call that B if you want to. But how do we set this problem up now?
8 squared
8 squared
plus B squared
plus B squared, very good,
10 squared.
equal to 10 squared. You see how it's a bit different from the other one? Because this time I gave you the longest side already. So let's solve. 64 plus B squared equals to 100. How do I solve for B?
Subtract 64.
Subtract 64. So if I subtract 64 over, I should have 36. Yes? How do I solve for B? Square root it. So B is 6. Now, what did we just find here? The 6,
B.
what does this represent?
B. The side.
The side of the triangle. Right there. That means the distance of this side of the triangle is 6. Did we answer this question yet?
No.
Okay, the only thing we know is this. You see how this 8, this is the length of this side, right? What is the length of this side? Should be. Think about it.
Is it 1?
What is it? 6. Exactly. If this is 8, then we know that this here has to be what? 6, isn't it? Remember, isn't it true that when we set up the slope, we are finding the length of the two shoulder legs?
Oh.
Is that right? And we just found out that the length of the shoulder leg is 6 here. But in this case, how do we tie this back in? 7 minus A
Side minus
has to equals to what?
6.
6. So that's the last step here that you need to remember. To find the coordinate, the missing coordinate, now you just have to set it back in. We want to make this 6, so we set it equals to 6. We solve for it. We know that the length is 6. That has to be 6, so therefore they need to equal to each other. So when we solve for it, minus the 7 both sides, we've got negative 8 equals 2. What is 6 minus 7?
Negative 1.
Negative 1. How do I solve for A? Divide by negative 1 both sides, okay. So A is 1. So that means the missing coordinates for that one is 1. That's it. 1, negative 3. And so this is the part that's a bit challenging because a lot of you would just assume that, hey, I'm done. It's 6. But don't forget that you are just solving for the length of the shorter leg, and that has to correspond to what it is right here, which is unknown at this point, right? Okay, remember when we set up our slope, we are finding the length of the two shorter legs of your triangle, but because it's a variable, we need to go back and figure out what that is to make it true. Okay, we know that this has to be 8, we already got that. We know that this has to be 6, so what does A have to be to make it true? In this case, A has to be a 1. Okay, alright, so with that in mind, go ahead and try this one out for yourself. Alright, so let's take a look at this right here. First of all, once again, I would definitely put up 2 points, just for reference. One point here is negative 4, 5. The other one is 3a. The only thing I know right now between for these 2 points is what? What's the distance between the 2 points? Square root of 58. So at least that is already given to me. Okay? Is that correct? And I can certainly do a quick path to show you the rise and run of between the 2 points. And let's figure out what we have. Remember, for us to find a missing side of a triangle, we need to have at least 2 sides given. Right now, we only have 1 side. So let's figure out the other 2. How do we find that? Subtract. Okay, so here's a negative 4 and 5. Here's a 3 and A. Subtract it. What do we have?
Negative 7.
Negative 7
Minus
and 5 minus A. And notice I circle this again. Remember that at the end, we're going to have to do something with that. So negative 7. Do we use negative 7 or do we use positive 7? Positive, because remember, it's a distance. So we just put that. So that's one leg of the triangle. The other one's missing, so what do we call the other one?
A. B.
See, why is it that I don't want to use A? Because if you call that A, are you mixing it up with the other A here? So try to call something different. Yeah, X is fine. So, how do we set this up? X squared plus 7 squared equals what?
58
Root 58 squared. See, this is the part that people kind of get confused on. Whatever side you have, you square it. That's just the basic rules, right? And now what you notice is we have a square root and a square. What will happen to the square and the square root? They cancel each other out. So you end up with just 58, right? 7 squared is, of course, 49. And how do I solve that? Subtract 49 over, right? So 58 minus 49? 9. So x squared is simply 9. What is x?
X equals 3.
Right. You take the square root both sides. X is 3. Now look, you gotta understand here. What you just found is the distance for that shorter leg, which is 3. What they want you to find is the missing coordinate to make it true, right? Over here, though, you know that this is 7, which is correspond to this side right here. This has to be 3, right? So that means what I circle right here has to be what? 3. So that means this has to equal to 3. That's why I set it as an equation to solve for a missing variable. So 5 minus a equals to 3. What is a?
2.
Okay, let's solve all the way. So minus 5 over here. I got negative a equals to negative 2. So divide both sides. So a is 2. Questions on that one? What do you think? So everything looks good? As is, right? Okay. All right. If you have no further questions, let's take a look at your recommended problems for today.